This video tutorial provides a demonstration of the contact debonding feature available in Ansys Mechanical using the cohesive zone material method by examining the displacement of two two-dimensional parts on a double cantilever beam. The beam is illustrated here. It is 100 millimeters long and it has an initial crack that is 30 millimeters long. Two vertical displacements, one positive and one negative, will be applied to the nodes at the corners above and below the crack to determine the vertical reaction. The point of fracture will occur at the vertex of the crack and the interface edges. Before beginning, I would like to point out that I have already created the necessary material properties for this analysis using the engineering data module. An elastic material is required for the interface between parts, called interface body material, and a cohesive zone material for the crack, called CZM crack material. I have imported the model into Mechanical, and I'm ready to begin defining the analysis. The first step is to define the two-dimensional behavior property of the geometry. To do so, I select the geometry folder. Then in the Details pane, I can set the 2D behavior property to plane strain. Next, I expand the geometry folder and select the Parts folder. In the Details pane, I set the assignment property to interface body material. This assigns the proper material to the parts. Now I need to define the contact region between the parts. Using the edge selection filter and the depth picking tool, I can easily reassign the interface edges as the contact and target properties of the contact region. Once complete, I will rename the contact Body in order to clearly identify the contact region for use later. I'll also verify that bonded is selected as the contact type and that pure penalty is set as the formulation. I also need to prepare some mesh options and controls. I'm turning the Use Advanced Size function property off, setting a default element size, and setting the Element Midside Nodes property to Kept. And I'm going to configure two mesh sizing controls for the edges of the model. These mesh controls help to create mesh elements that have a fixed size for the model as well as along the line of interface to lamination. Once I have completed my sizing controls, I will generate the mesh. At this point, I can specify the contact debonding object. First, I insert a fracture folder into the tree by highlighting the model object and then selecting the fracture button on the Model Context toolbar. Then I can select the Contact Debonding button on the Fracture toolbar. In the Details pane for the new contact debonding object, I'll set the material property to CZM crack material, the material that I defined earlier, and I'll set the contact region property to Body. Before going any further, I need to configure a few properties in the Analysis Settings object. I need to set the Auto Time Setting property to On, and then enter 100 for the initial substeps, minimum substeps, and maximum substeps properties. Now I'm ready to define the boundary conditions for the analysis. A fixed support and two 10 mm displacements, one positive and one negative in the y-axis. Finally, I need to insert result objects and solve the analysis. For this analysis, I'm going to examine directional deformation on the y-axis and a force reaction of the positive displacement. This animated result shows the Mode 1 debonding for normal separation. Another beneficial result to examine is the maximum stress. Notice how the point of maximum stress in red, moves along the separation, the line of delamination,